Okay, so just a little kind of introduction as to what we're talking about today. We're going to be talking about mapping urban streetscapes with the ZEB Discovery. And presenting today is myself, Madeline Lake, as a key account manager here at GeoSLAM. And then Joanna is who's a senior application engineer, will be talking us through Orbit and some of the key features that we can use Orbit for mapping those urban streetscapes. So we'll kind of swap presenters partway through, and she'll be able to talk us through some of this slightly more technical content there. So as questions come to you as we move forwards, please just use the question and answer panel. We'll go through those at the end and make sure that we do answer those questions. And also, if anything comes to you after the webinar that you do want to discuss with myself or Joanna, please, you can also send follow-up questions to info@geoslam.com. But please don't be shy. We'll try and cover any questions that we can and go through that after we've presented some of this material to you. So, you know, GeoSLAM is the global market leader in Go Anywhere 3D mobile mapping technology. And traditionally, our technology has sat in the space of being able to capture data in challenging environments that don't have GNSS or maybe even underground and are difficult to access. And kind of as we move forwards, we're also looking at having the versatility and adaptability components to our technology too, so that, you know, you're going to get the most out of your money, the biggest bang for your buck, as it were, when you buy our systems, because you can use them for a wider range of applications and have the flexibility to do all of the data capture on site that you might need to. As a company, we're really focusing on building strong partnerships with other businesses that are disrupting the industry by being able to move 3D spatial capture forwards and make it more accessible for people. So again, we're looking at making sure that it's as efficient as possible in terms of cost of solutions, but also being able to pull together different experiences and make sure that we are thinking about you and your customers' end solution and what it is that you're actually trying to achieve when you capture the data. So that's sort of an idea of view of where GeoSLAM see ourselves currently and where we want to move forwards as we go in the future. So I just want to show you on this slide where you can find us. We've got 7 global offices. You know, I think it's actually 77 distributors, but potentially there's a couple more recently onboarded, so that would take us up to 80. And we're in 53 different countries. We truly do have a global offering and a very strong support network out there. We're hoping doing these webinar series that we're able to reach a broader audience from our Nottingham HQ. So we've got webinar events that happen in UK time at 7 AM, 12 noon and 4 PM. And we'll also be recording all of these webinars so that if we're, you know, catching you at inconvenient times or this isn't the right moment for you to listen in, you'll always be able to hear us later on and come back and use these webinars as a source of information and to make sure that you kind of fully understand what GeoSLAM have to offer. So I just want a little bit of a note again as to what we're really trying to do now at GeoSLAM and moving forwards. And we really want to collect, but then connect the data from the world around us. So, you know, we're talking today about the ZEB Discovery and urban mapping. And I feel like the ZEB Discovery really is a big step forwards for GeoSLAM because it's our first foray really into integrating multiple high quality sensors together to give you an enriched 3D data set that's going to help you make the most of any data capture that you do and give you a full solution. So, you know, GeoSLAM offers mapping and monitoring solutions and that don't require GPS. And that's a really big point for us. We don't want to limit our customers to only being able to capture data in areas where you have GPS and, you know, only working in certain conditions. It's really important to us that it's our SLAM algorithm, which is data driven, and it's been out in the market the longest, which is what gives us the incredible solution of being able to get sort of 1 to 3 centimeter accuracy with our point clouds. And that's what we're using when we're creating the trajectories, and we're creating these 3D maps. We're using our SLAM as the basis for that, and as the structure of all of the data. So we're not being reliant on GPS or having a strong signal connection to the GPS. And so I feel that's it's a key point to all of the GeoSLAM products. And so with that in mind, you can see why we've been so successful in these challenging environments where you wouldn't normally be able to get good quality mapping data. And then moving forwards, we're really looking to be able to be used in multiple modes, so that you can use our system for capturing all of the different environments that you might be looking at. So just as sort of a refresher, I'm sure you'll be aware of the ZEB Discovery by now. We've done a lot of shouting about it because we're very proud of it. But let me just give you a sort of a recap on quite where we are with the ZEB Discovery. So it's synchronizing data from the ZEB Horizon that you can see there on the backpack, which is our handheld LiDAR scanner system that we launched last year. And that's a LiDAR sensor that's powered by our industry-leading CT SLAM algorithm. And then we've paired that with the high-resolution camera, which is going to allow you to rapidly map urban environments. And the key thing there is that we're linking the very accurate, high quality LiDAR point cloud with high resolution imagery, so that you can then get more information on the world around you. The way we interact with the world is that we see it in pictures. Pictures give us a much higher resolution of information in relation to things. You think of these urban environments that you can be mapping, there's signage, there's all sorts of information. And so for actually being able to see those features, identify them, understand them, having the images is really important. But linking those images then to our very accurate 3D point cloud is what's going to give you the confidence that you're making the right measurements and that it is representative of the world around you. We've already talked about the fact that you don't need GPS when capturing with this system, but we have got a GPS sensor as part of the package so that you can know where you are. It's sort of accurate with about 2 meters, and it's the ideal thing for just being able to know, okay, exactly which junction was I at when I was capturing this? Where was the area that I was walking in? And that's kind of how we want people to view that part of the ZEB Discovery. Now, Orbit GT software is a really important part of the ZEB Discovery package, and particularly when thinking about mapping an urban streetscape. The Orbit software is what we're using for viewing the laser and image data together. And Joanna will go through with you shortly some of the cool things that you can do with the data and how that looks. She will be very well placed to kind of show you how you can use it. But the important thing there is that Orbit really have a lot of features that's going to help you have a solution and a product to deliver to your customers, thinking of feature extraction, being able to make important measurements and the like. And part of the thing with Orbit is that in our workflow, it's semi-automatic, and there's automatic localization of the images within the point cloud. So in the sort of the workflow, you'd be processing your data in GeoSLAM Hub. Meanwhile, you use the ZEB Discovery image processor to bring the images together and have them aligned properly. And then you bring all of that data into Orbit, where those images are then automatically localized for you within Orbit. And you see something that be sort of very reminiscent of a Google Street View. It helps you navigate very easily through the software and really see and understand the data that you've captured quickly. Speaking of speed, though, the actual capture is a dream. You just press a couple of buttons, you turn on the scanner, you turn on the camera, you wait 60 to 90 seconds, and off you go. You can start capturing data straight away. It's very lightweight. It's around 9.5 kilograms. So it's not something that you're going to get too tired wearing. So you can use it anywhere really that you can walk and stand. Joanna, I know, only this week found herself wearing it whilst cycling on a bicycle, and it's amazing the distance you can cover there in the sort of 20 to 25 minutes of capture that we recommend with the ZEB Discovery system. I mean, I guess that's just a key point to remember, is that, you know, when capturing data, think of all of the key constraints that we have and requirements when capturing with the horizon, i.e. we want the data capture length really to be to a maximum of 20 minutes, 20 to 25 minutes at a push. And that's what's going to make sure that your projects are of a manageable size in terms of the data that you have, you know, particularly factoring into the fact that, you know, high resolution imagery is a little bit more, produces a lot more data than the LiDAR point clouds that you'd have just from the horizon scanner. But it also, having a shorter, well, a 20 to 25 minute capture time also really helps have a really good SLAM solution. And that's what we really want, because we want to have a nice solid structure of the point cloud such that you can then add in the imagery and make those really really accurate measurements. That's going to be what your customers are looking for. And, you know, just a note again is into sort of how we're really trying to make the system being flexible and adaptable, is that you can use the system as the Discovery as a backpack, but you can then also just clip and go with the horizon LiDAR scanner and have it in the handheld function. You can see actually on that picture there, you can keep the handle on the system when the horizon's on the backpack, which is fantastic. You can unclip it and pop it onto the UAV as well, you know, if you want to capture the area from the sky. And then also we have a vehicle mount that's in a kind of a prototype phase, and we know that we do have customers that are already have been utilising the horizon scanner on their own vehicle mounts, and they're having great success with that. So that's something that's kind of becoming in the new year. And then just to kind of talk you through, so software, you know, the Orbit GT software is for helping us capture, model and share 3D mapping content. So typically the structure with Orbit software is that they have Content Manager, which is used to manage and optimize the mobile data once you've captured it, and kind of helps you organize it. It's a sort of a very, very good way of managing it within a sort of database. Then there's the feature extraction component, which is the thing that we're most excited about, where we're looking at being able to pull the assets and the information from the data. And then the publisher component, which is what would allow you to share your data in a web viewer, so you can share that with a wider audience. Now, what we've done is work with Orbit to kind of put together a bespoke bundle for us, where we've focused on the feature extraction, so what Orbit GT refer to as their standard feature extraction. So we've got all of those kind of components. You can see there on the slide I have in front of me what those are. So being able to import and optimize the data, view the data in 3D, use vector data, inspect the objects, do the measurements, look at contours and a bit of volume analysis, you know, some of the semi-automated measurement tools as well that Joanna will show you in relation to white lines in the central area, asset inventory, you know, all of this key stuff that you're going to be wanting to deliver when you're doing urban mapping. But then in the little orange box, these are sort of 4 extra things that we've put into the bundle, which are really coming from the Content Manager, where we can now colorize the point cloud, which we're very excited about, and Joanna will be able to show you that. A bit more on the georeferencing, so being able to use control points and georeferencing the data, and also do any additional calibrations. So one of the points is that when we kind of go through the process of delivering your Discovery system to you, and we do a couple of days training with everyone when they get the Discovery, we'll talk to you about the calibration. And we do a very specific calibration to begin with, that's then going to allow you to clip and unclip your horizon without the need to regularly calibrate it, whilst you're capturing data. But we also want to empower our customers so that if they did unscrew the camera or they felt there was a bit of a misalignment in the data, we'll show you how to do a calibration utilising Orbit, and we can make sure that you're having the high quality data that you're looking for. And then we also have the ability to catalogue the data and upload that onto a web viewer. So just in case then none of you have seen what this data looks like in Orbit, Joanne will be showing you something much more in a moment, but just to sort of get our eye in to what you have in this urban mapping environment, this is what your data can look like in Orbit. So this was a 15-minute bit of data capture that we did around London, and we were able to really harness the key wonderfulnesses of the Discovery, because we could get places that you would never be able to cover in London on a vehicle in 15 minutes. But here you can see that you've got the map page across the top, which is utilising just our GNSS signal when we were capturing the data. So as I say, it's around 2 metre accuracy. It shows you where you walked, you know where you were, you know what it is you're looking at, super useful. And then in the bottom 3 screens, you can see the different views that we have of the data. And Joanna, again, will talk us through that, because there are the ability to bring up these different viewing panes is then really useful when you're trying to look at the data and manipulate it and get the information out, because you can control how you view the point clouds, whether you want to see the points at all, how you're measuring it. So Joanna will kind of go through that with you. So just to kind of bring us back to the point at hand, important to remind myself of that, is that we're here today to talk about street mapping, specifically with the ZEB Discovery. And so I thought it would be good to just kind of think through what some of those main challenges are that one faces when street mapping. And I think that, health and safety really has to be at the top of that list. It's a real challenge when you're capturing busy environments, busy road environments. If you're using static systems, does that mean that you're going to be out in a potentially hazardous environment for a long time? How can you kind of try and keep your workforce away from moving traffic? How can you make it as safe as possible? How can you make this a system that's easily deployable and is going to get you great results without putting anyone at risk? Another key problem is then it's all well and good that you can map, a straight road for 50 meters, but let's be honest, most of the jobs that we'll find ourselves doing is they're very complex environments, multi-level street environments, where there's a dynamic interaction in that space, be that with transport, buildings, other users. If you might need to capture the inside foyer of some of the buildings, there's always going to be more information that you're going to want. If your customer, for example, if they want to be capturing the data because they want to plan where to put signage, they need to look at that from all sorts of views and all sorts of different places. So you're going to need a system that can capture data in all of those different urban environments comfortably and give you a unified data set. Access to the site can often be a problem as well. You might be struggling because the area is pedestrianised, you can't get vehicles in, or it might even just be a timing thing. You have to know that you're going to be able to capture a lot of data quickly when you do have that access, and you can go so that you can get a reasonable amount of work done in a day or in a session to make it financially viable too. And you need a system that is going to be able to cope with high traffic levels, and I mean that in terms of road traffic and pedestrian traffic. You don't want to have a system that's going to get fuddled by the fact that it's had lots of people walking past it, or that needs a fully clear environment, because if you're going to be looking for that in an urban centre, then you'll be waiting a rather long time, I think. And that kind of comes to, particularly thinking of some of the high-rise urban areas that we've been testing with ZEB Discovery, is that the GNSS or GPS signal really can't be relied upon. Some areas it's fine and it's great and you can get that lock and it's lovely and you can still very much use our GPS components, so you can have the map and see where you were. But we have also had moments where we fully expected to have GPS signal, and for whatever reason it's just not there. Maybe the building is too high, or the signal's being blocked, and it's just so wonderful to have that confidence to know that that's not going to be that's not going to be a stopper or a blocker on your day's work. This is going to mean that you can really move forwards and get work done. And maybe you'll have to use a control point later on just to know where you were, or you'll have to find some other way of geolocating the data. But at least you'll be able to have captured the data and move forwards. And I think that really then leads in nicely to thinking about, you know, costs to the client. As a major challenge of street mapping is that there is a limited budget. There's only so much that someone is able to spend on getting this information. So we really want to focus on making sure that we have a solution that is going to fit within these budget requirements, and is going to give you data, and you're going to get a good output for the amount of money spent on any sort of project. And then I guess the other thing is, you know, we want to limit the disruption to as low a level as possible. We've all had frustrations with different traffic management systems being put in and areas being blocked off and not being able to get there, and it's a real inconvenience. So, but I think that's a real key challenge of street mapping, is to try and make it as what's the word, like non-invasive as possible. So yeah, those are some of the challenges. And so now let's just talk through, and I've probably said all of these, so bear with me, but how we think the ZEB Discovery excels at street mapping. You know, we don't need GPS. We've covered that. We really don't need GPS. We can still generate a 2 to 3 centimetre accurate point cloud. You're going to get some good results. We have the ability to bring the images and LiDAR together, as I was saying. So yes, of course, you could always just use the Horizon as a handheld or UAV mounted or vehicle mounted scanner, but actually sometimes you're going to need a bit more information and detail from the environment around you. You know, these are information rich environments. There's lots of details. Having the imagery is really going to help you look at the data and get the most of the information from it. We've got a 100-meter LiDAR range on our scanner, so that's really going to help capture facades on buildings. And it's also going to help with the accuracy of our SLAM. So because we've got a nice long range, it means that we're using lots of features and feeding all of those in to our industry-leading SLAMs. That's giving us a really nice accurate result that you can then really confidently make measurements from for your urban mapping. We've already talked about the flexible mounting options, so being able to transfer from the different modes throughout the day, depending on where you are, so that you can have this cohesive data set at the end, I think is a real asset, and particularly being able to then pop it onto the UAV and get the roof or something else that you really won't be able to do if you didn't have that flexibility. The semi-automated processing workflow, you know, we know that as soon as you've captured the results, your customer wants to have that delivery. And if we can reduce the processing time and reduce the lag time from you capturing the data to you being able to deliver your results and get paid, then that's going to be another big win for both you and your customer. And I mean, I guess I've been going on a bit about our SLAM algorithm, but I think it is important to point out a big benefit for us in the world of street mapping is that we're not reliant on a hardware synchronization between the camera and the scanner to create these fantastic results. The wizards inside our product team have been able to create a solution that utilizes software to synchronize the images and point cloud together, which means that the two components don't need to be synchronized when you're actually capturing the data. And that means that we're not reliant on dodgy event cables or anything else that could you know, make a situation a bit sticky when you're out in the field capturing data. And it gives us more facility to cope if there was any problem with the data capture. You know, it gives us more flexibility in coming to a good solution without having to go out and recapture data, which is what we all want to avoid doing. I've already talked about not needing to do a lengthy calibration or initialization at the start of the capture, and the fact that you can use control points. So look, we're saying that we think our solution is brilliant and great at just using the SLAM algorithm and having the pictures. But if you need to put this data specifically onto some control points, maybe you want to look at change over time or look at some other features, brilliant. Orbit can use control points. So that's that's the big win, and that means you can move your data into the right place. And we have the GNSS, the GPS sensor, that's going to help you know where you are in the world. And I guess going back to that point that I made earlier about busy pedestrian areas, and you know, you need a system that won't be put off because it's been had lots of people walking close by or in a very busy area. Our SLAM is fantastic at dealing with people coming in and out of its field of view and just eliminating them from the point cloud data. So that's not something that you need to be at all worried about with our systems. So I guess just before we move on to sort of the orbit component and Joanna showing us some of the how the feature extraction looks in orbit, I just thought I'd jog our memories and think of all of those things, those key features that we're going to be wanting to pull from the data, what our customers are going to be really motivated to be able to know about. And you know, it's all of those things like road marking, street signage, curbstone height, street lamps, traffic lights, all of those things, and as you can see, lots more. So there's all sorts of information to be pulling out of this 3D data and to really enrich the deliverable that you can then pass on to your customer. So I think there, if you just bear with me one moment, I'm going to switch Joanna over to be the presenter, and then she can show us some of the fabulous things with Orbit. So just please bear with me for one moment, and I'll switch across to Joanna.
Okay, good morning, good afternoon, everyone. I hope you can see me and you can see my screen and hear me well. It's Joanna here, and I have prepared a couple of slides to show you the capabilities of Orbit, as Maddie introduced, and how to actually do it with our data, with Discovery data captured in different places around the world. We have been having the system on the market already for some time, so we are collecting quite a lot of different data sets, and we can show you now a couple of examples. So one of the first thing I wanted to show you is just the Orbit introduction, how to visualize and navigate through the data, and how to really read it and how to understand. So I prepared a video here just to play it, and then I will talk through that video as we play. The top view in Orbit always shows the overall project. It will show your trajectory, so positions of the images, point cloud. You can swap it between map 2D and map 3D. So at the moment I'm showing map 2D, so only looking from the top. You can quickly swap it between 2D to 3D to actually rotate, zoom in, and look at the point cloud itself in the 3D environment. This top view always also has a possibility to show a base map. So as you see on the left side and the legend, there's an OpenStreetMap. So we have some data that are georeferenced, some data are just in a local coordinate system as it comes from a SLAM device. And I will show you later different examples of that too. Here you can also change the way how we display point cloud so that it can give you different information as necessary. Some people are used to different scales for intensity, for height, and so on. So this gives you a possibility to do that. You can select colors, you can adjust it to your needs and actually get the information from the data that you need. You can see that it shows quite well the different surfaces, different objects in the data. You can also see that we had quite a bit of traffic on the street. There are cars, people moving around. That is not a problem for the system. Our SLAM solution works very well with that sort of environment. In Orbit itself, there are a couple of different options to clean such a point, such areas. You can either do the semi-automatic with ghost cleaning or actually by selection tool as well. So that is not nothing to really be concerned on. So intensity really gives the best view and understanding, but there are, as you saw, other also options. So I would recommend, and I normally keep my point cloud in intensity and just change the scale as required. And then the second way how to investigate, how to visualize the data is to open an actual image or images. You can open multiple images at the same time. So at the bottom, you can see now the panorama image that are clicked on the top view at the position that I wanted to visualize, and it brings me the panorama from that position. You can rotate, zoom in, zoom out, and then overlay the point cloud on that image as well. Even if you don't overlay the point cloud is behind the image anyway. So we could switch off the point cloud, and then the measurements would be still done with the point cloud behind the image. So again, here you can change the way how the point cloud is visualized here. The same principles: height, distance, intensity, RGB, if you do have the RGB. Point cloud is displayed as a radius from the position of the image. So everything that you are seeing here is positioned to the image where it was captured, and then the point cloud is actually displayed from that very position, and we can define how far we want to see and how long distance we want to see of the point cloud. You can also visualize data. You can open images, multiple images based on direction that you want to see. So you don't have to click on the actual position. You can actually just decide that you want to look towards that wall, and it will bring you the closest images available for that. So this was just an overview and intro to the basic visualization and actually how to navigate through the point cloud and images. We will have a more examples of different features and options just later on in a couple of slides. So if I go to the next slide, this is a very short video just as a different type of data navigation in the orbit. This one was captured in Paris some time ago already in just a housing estate, but you can see the zoom in, zoom out option, rotation, and you can step through the images as well. So let's say you define one image on one side, the second on the other side of the street, and you can step through those images at the predefined distances per, let's say, every second image, every fifth image. So going more into actual options, what you can do with your data once you import it and visualize. I think Maddie mentioned that all of our really files that we create from this software packages that we supply with the Discovery are compatible and straight away ready to use with Orbit. So there isn't any additional steps. Whatever it's coming from our software, you just take it to Orbit and import. In here, some basic measurements that are worth mentioning. You can measure distances, and there are different techniques of measuring distances available in Orbit. You can do it based on point cloud. So on that screenshot, you can see on the right side of the picture, I visualize only the point cloud, and I can do the measurements from that. I can do from the images, but with the point cloud behind. So I can do it as on the left screen. Or I could only use images to create a forward intersection if needs be. Everything really that is captured in a point cloud, you can measure. You can measure the distance, you can measure the diameter, you can measure the area, you can measure volumes. So anything that you can really see in a point cloud, you can then create the measurements of that. And as I say, you can do it based on the image as well. Then there are multiple lines that can be added and can be created in Orbit. Some of them are automatic, some of them are semi-automatic, and then obviously a manual as well. So we can show you some white lines detection, some curves detection as well. You can detect areas, as I mentioned earlier, just as simple manual areas, however you draw it, but also you can have a semi-automatic crosswalk detection in Orbit. Circles and points are very useful for manholes, for example, to detect the center of a manhole or the actual diameter. You can then save it and store it in your asset inventory, which I'm going to talk in a second about. There are also lots of options to perform catenary measurements, so power lines, telephonic lines, and so on, and they are also semi-automatic. So here on that screenshot, you can see just a simple measurements of the height. You can do it from the point cloud on the right side, from the image on the left side. And you can also see the crosswalk, but I will show you this how it's done on the video actually. So one of the first things I wanted to show you, just actual thing how it works in the orbit, just to give you an idea, is to how to detect white lines. There are different methods of doing it. Basically, it does read intensity from the point cloud and detects that accordingly. So let me just play the video and show you. So you will have to point at least 3 points on the one or on the other end of the white line, and then the second one. So I click only 3 times, and then I have to wait a little bit to see how many lines can be detected. Obviously, if there are some, let's say, some other points that are overlying the white lines further down the line, it might not detect all of them at the same time. But as you can see here, it went pretty much to the end of the street and detected the white lines automatically, well, semi-automatically. And what I've done just now is to save those lines, those vectors, to the vector layer that I've created previously, so that I can start building my asset inventory. So Orbit has the full workflow for creating asset inventory, to create attributes for each of the assets, to extract those features and add libraries and markings to the requirements that you have. So then you can basically start building your entire libraries and attributes, where you can define the types of the lines, the length, positions, and so on. So this one was a quick example of that part of extraction. And then if we go to the next one, just in the same topic really, but a little bit different, to show you the differences in the techniques of measurements, because that's quite important. If we want to do something semi-automatic, we need to change some of the measurements preferences. So here on that video, you can see that I have already a little bit different cursor, which actually looks at the corners and ridges of the point cloud. So if I define the correct parameters, if I define correct distances and other things, I can quite easily detect the ridges and corners. And that can be utilized not only on the streets like this, it could be utilized with the buildings, inside, outside, to detect those lines more automatically. So this is also a vector created for me, and now I can copy that again to the vector layers that I've created, with the attributes tables that are predefined and programmed. So that's just another way of doing it, and there are different techniques based on the one point click, multiplied point clicks, and so on. But in general, if you do have a good preferences set up, this is gonna detect it quite nicely from the point cloud. So here, again, still in the same sort of topic of different types of street features like white lines, curves, and now crosswalks. I know that some customers have to detect it, have to draw it on the map to then deliver to the customer. So here we have an example of that being done on the same data set. As I mentioned, on the right side now, I open the only point cloud, because you can do that as well. And some people do prefer to work on the point cloud and then having image only on the other side without the point cloud, or with point cloud, just for a reference as well. And that's something that we can do as well in that software. There's lots of really options for different customers to find their best way of work. So here I also have to click on I think 2 points only. So I need to predefine the setting. So I need to know more or less what's the size of the white lines, of those crosswalk lines, and how far apart they are. But they are quite standardized, so there are not that many options to choose from. And once I do that, and then I can basically click into places, and it will fit the vectors and areas basically in the point cloud. And it will also draw it directly on the map, which then can be saved to the vector file again to create the asset inventory and create the libraries with those. On the right side, you can also see information from that feature the actual area. So everything that we do here, that will save the distances, the length, the areas itself. So the information numbers will be there too. So now going a little bit towards different features that you can use and different environments for customers that are wanting to use that system within the forestry or trees, parks, and so on. There is quite a new, actually only recently released feature by Orbit, which is a trees detection, and that allow you to really, by one click, measure the diameter and the height of a tree. So let's see that video. So again, we have displayed both images. We don't have to. Sometimes it's just nicer to have it to check whether it's all good. So that could be done as well. So as you saw, I just click on the actual tree, and then after a few seconds, the tree was analyzed, and then a vector for a height and diameter was placed in. On the right side, I'm just checking this in a point cloud, because from the perspective of looking behind them from below the tree, it might not look that it went correctly, but actually on the right side, when I open the point cloud of the same tree, you can clearly see that the height is measured to the top of the tree crown. And then a couple of other examples, as mentioned, different types of data sets as well. I wanted to try and show you. This data set was captured in Tokyo, Japan. And as you see, actually, this data set has a base map. So that means that it was georeferenced by our technique. As Maddie mentioned, it is to locate yourself in the right position in the world. So you can see that I can detect which streets I've been walking with the system. And then on the bottom part of the screenshots, you can see a point cloud only with intensity, and an image that represents that looks at the same part of the point cloud to actually see the data better. So you can see the intensity, how well it also preserves the different shapes and different white lines and the signs on the walls, which is very useful as well for them investigating the data. And here I was just showing a little bit of the functionality for the manholes for circular detection. Very easy, and all the information on the right side, the length, the radius, and XYZ for center of the manhole are stored there, which also can be then stored to your asset inventory table. Excuse me. Here is just a different example of also vectorization and road markings. Some of them can be done semi-automatic, some of them would be manual. But here, because we have intensity quite well, we could have drawn that with one click really of the button. So just not to get too long and too many examples for you to not get that too stretched, here are just a couple of more in one slide from different parts. We have some of my colleagues in USA with systems at the moment, so they've sent me some data back as well, which as you see, there's different ways of detecting curves and lines. Then we have a Montpellier example of the data with the catenary, so power lines detection. This sort of detection takes around 3 clicks to get the line fitted in the point cloud, both ends and the middle of the point. Then just at the bottom is an example from Tokyo, Japan. That's a capture that was done both in the underground parts of the city and also on the street. So you can see that in the same sort of session, the same project, we can go both outside and inside, and we still have really good imagery. We still have a very good point cloud, and we don't need to struggle with processing of that without the GPS. Here, just also something quite interesting, I think, and useful is the slice views, which can help a lot to do vectorization and measurements as well. So one of the top view is the Nottingham scan in UK, where we are based actually. This is just the old town scanned within 5 minutes time, and we can see quite nicely vectorization and measurements of the area of the old church. And on the right bottom side is the Tokyo again, with some of the buildings being vectorized as well. So those were slides that kind of shows the basic measurements, some semi-automatic, some manual, but this is to give you an idea that that's how Orbit is working with the data. There are also kind of quite a few others that are a little more advanced. I think we will plan for some other webinars next year to then go more into advanced options in Orbit. So here is just an example of the data from Tokyo. This one is in intensity, sliced view. And then the next slide shows the same point cloud, the same slice in RGB already. The colorizing is done in Orbit. So that's something that our bundle, our Discovery Orbit bundle includes as well, that you can color the image, point cloud from the panoramic images. If I go a little bit forward, there are a couple of other examples of the colored point cloud. This is showing you in 3D, so that's from actually US, very recent capture of the city center really environment. Here we have facades of the buildings with actual colors and correct numbers on the windows and displays. So that's really, really helpful and can give you really quite good information on it. So you can see that the coloring works very well. This is also a nice example of the city environment, which is colored with the lines, white lines and the yellow lines, quite nicely picked up by the colors and visualized very well. And then as a really finishing that sort of presentation of the capabilities of Orbit, here's the short video showing displaying really point cloud from Discovery from US, again the same as just on a couple of screenshots earlier, in different modes. So it was RGB, then we have intensity visualization, and then we would have a height as well. So that's also done in the Movie Maker extension from Orbit, which allows you to actually create such a visualization of your point cloud, and you can swap between RGB intensity and height in between those that video to just show different really options. So from my side about Orbit as an introduction and the features that are useful for mapping, that's really all at the moment. As I mentioned, I'm planning for having some more advanced webinars coming next year, but I think this is quite a good example how you can utilize that software to actually create a full end-up solution map or asset inventory as well. Okay, so I think the next part will give a voice back to Maddie, and I'm gonna have a look if you do have any questions, if you can pop them into the question panels here in webinar. I would be trying to read them through and then prepare answers for them, if that's okay.
Hello there. So hopefully you can hear me now. So just as Joanna has a look through the questions, I just want to kind of summarize what we've got here and really remind you again where we are with the ZEB Discovery, and that, you know, we've very much created this product based on customer feedback, you know, asking for an easy to use system that's going to enable us to use high resolution imagery to supplement the already fantastic accurate point cloud that we can capture with the horizon. And we're really looking at the Discovery really opening up the possibilities of data that you can use for modeling 3D environments, those feature-rich environments where there's just a bit more information that you want to get from it, and deliver a slightly higher level product to your customer. So, you know, please do very much keep ZEB Discovery in mind for mapping urban streetscape environments. It'll allow you to keep your team safe, because you're going to be limiting the amount of time that they're out in the field and not putting them statically in dangerous road positions or anything. You'll be able to save that time and really reduce the amount of time that you are out there capturing the data, but also the time it takes to turn around that data so that you have something to give your customer at the end. Save resource, because you don't need a large team out there capturing data. You know, this is definitely something that you could do by yourself, or maybe with another colleague to work as a team and take it in turns capturing data and then finding the right way to process that data and manage that. The system, because we're able to give you the ZEB Discovery utilizing the horizon and all of those other kind of capabilities that it comes with, we really are lowering the cost of data acquisition, because now you get 3-4 systems in one, so you're only needing to have investment in sort of one type of software, one type of solution, and it's naturally all going to come together much smoother than it would if you were trying to use lots of different types of products to capture the different environments that you need to do to complete your project. So, very much keep ZEB Discovery in the forefront of your mind, particularly, considering the fact that we are utilizing the Orbit GT software, and that's really going to give your customers a full end-to-end solution. So I think Joanna, if we just move on to the next slide, I think that, yes, so we just want to give people the details on how you can buy a system from us. So we have a global dealer community, 77 to 80 dealers. You can find your local dealer on our website on the how to buy page. And also we have a little SLAM bot on there where you can do a live chat with one of our sales teams. So that'll help you get going and find out a little bit more about the system if you need to do that too. And so now I think we have a little moment if we do have any questions. Joanna, have we got any questions in that we need to have answers to?
Just looking, I think we have one here about processing times and basically maybe data management, I see, of that discovery system. So answering that, really, it depends really on, what are you scanning, how long are you scanning for, and what is your computer really specifications. So obviously a better computer with more memory RAM or more better CPUs will give you faster results. But essentially we are working on having a system as easy, as simple to use, and as fast to be used really, and to deliver the results. So all of the as much as we can, we are improving the software part, and so our software to process point cloud data is constantly improving, and that only requires you to drag and drop the data very quickly and then wait for SLAM algorithm to process that. And then on the side of images, we are stitching the images also in software that we developed. Obviously we are relying on the SDKs and information from the manufacturer and CTEC of the camera. And here, this depends on how many images you are collecting during the scan data, during the project. There are different options of setting up the camera. You can set up it can capture up to 7 frames per second. So that's something that is the maximum. And if you do want to get most of the data, so you can then decimate the images based on distance or based on different frame rates, you do need to capture 7 frames per second. So that will be quite a big data set, but then you can decimate it afterwards. Or the other option is to make the decimation already during the capture. So then the actually amount of files, raw files, will be smaller. But that's why it is a little bit difficult to really say what it is exactly the time. The most really time consuming will be images, but it will depend on your computer and also how many images you are collecting during the project. So if you are more interested, or any of you guys, please do contact me back. We can discuss this a little bit more in detail, and I can give you some numbers from the experience that we have so far, because we have been capturing lots of different data sets and different types of decimation has been applied. So we can discuss that for sure. I don't see any more questions at the moment. If you guys have something else later on, no problem, come back to us as well. Maddie, is there anything from your side at the moment?
No, I think that's fantastic. So please just, if you remember, you can find other webinars that we have on our website, check the schedule, see if there's anything that stands out to you as another topic that you'd be interested in. And we'll be sending out a recording of one of these webinar sessions to everyone that's attended, so you can have this as a record, just in case there's something that you want to go back and revisit. So thank you so much for joining us. It's been a pleasure for us to talk you through our ZEB Discovery solution for urban streetscape mapping, and we'll be in touch with the next webinar on the schedule. All right, thank you so much for joining us.
Thank you very much. Bye bye.